Hello, my name is Eglė and I work at Fish Ecology Lab in Lithuania, and today I will ask you one particular question. Is more data always the better? We know that stock assessment should ideally be based on time series long enough to represent the full range of change and address shifting baselines. Otherwise, we can miss maximum biomass, all the past recoveries and declines, population's ability to recover, etc. However, in reality, oftentimes shorter time series are selected for these stock assessments. Our case study is Curonian Lagoon in the Baltic Sea. It is a shallow and very productive water body, and we have data since 1947. This dataset that we have includes a wide range of fishing gears and data collection methods, and encompasses periods before and after the onset of the intense industrial fishing. So we have a really long dataset, but it's a difficult one to use because of so many changes that happened during that time, both in sampling methods and ecosystem itself. First, let's take the simple example and the simplest model, CMSY, and we may see that Bream is probably doing not so great, although uncertainty is big. But can we get more reliable and more precise results by including more information like scientific catch per unit effort estimates? Here it gets tricky because, as I have mentioned, the protocol for fish scientific surveys varied during this period, and we try to standardize catch per unit effort using GLMs. And not surprisingly, you may see that error bars are big for the old years in this case. So now we have catches and CPUE, so we can apply surplus production model and include catches, CPUEs, and uncertainty of the CPUEs. Again, uncertainty is big, but results are now more optimistic regarding stock status. A different story is with the pike perch. CMSY shows relatively stable situation for the last decades. Although uncertainty is so big, it could be anywhere from increasing to decreasing trend actually. And this is mainly because catches have been basically constant for the pike perch for the last few decades, while catch per unit effort shows clear decreasing trend. So what shall we trust more, catch per unit effort or catches? Surplus production model results, in this case, did depend a lot on the uncertainty of the catch per unit effort, and since in this case uncertainty was big and varied so much, we cannot really get good fit of the model when we use the whole time series. But if we use truncated time series starting from 1992, when the standard fish monitoring took place, we then get clear trend and actually a really bad stock status for the pike perch. So the more the better, I can agree with that, probably, but making use of the long-term data is still really challenging. We had very high uncertainty of the all year's catch per unit effort, but despite this high uncertainty, including this CPUEs in the surplus production model provided useful information, although it was species specific. Thank you very much for your attention. I would be more than happy to hear all your suggestions or answer your questions. Please contact me via email.